going to discuss exponential laws or the rules of exponents. By knowing these sets of rules, it will make it a whole lot easier for you when you are calculating exponents in a given equation. Okay, so there are different types of rule, and I will go through each one of them with an example. So let's start first with the multiplication or the product rule. So if you have the same base but the exponents are different, what you can do is you can actually just add them. So in this case, if I have x raised to the fourth times x raised to the fifth, take a look at the bases. Both of them are x, so basically I can just add the two. So my answer is x raised to 9. Okay. Now, if there are two variables, x and y, the same rule actually applies as well, but you have to group it. So in this case, you look at x, they are the same, you just add them, so you get 4 plus 2 is x raised to the 6th, and then you have y raised to the 3rd times y 5th, you have y is equals to 8. Now, one of the most common mistakes that students make is trying to add exponents when they are not the same. Okay? Like let's say if you are given x2 times y2, you know that the bases are different, so this rule will not apply. Okay? Another common mistake that most students make is, let's say you're given x squared plus x squared y squared. Okay? Sometimes you can get easily confused because, as you can see, there are two same bases. The other one also has x raised to 2 and the other one has x raised to 2. But if you look at the operation, it's addition, so the product rule cannot apply. This is not equal to x4 y2. So just keep in mind of this mistake in order for you to avoid it. Okay. Now the quotient rule is just the opposite of your product rule. If you are multiplying exponents with the same basis, for quotient rule, if you are dividing exponents with the same basis, you will just have to subtract them. Okay. In this case, they have the same base, so you are left with x raised to 12. So 15 minus 3. Now, for the second example, you have two variables. Okay, and this one can get a bit tricky because the other one has a higher value. So what you can do is you can actually do like this. So x 5 minus 3, and then you have y is equals to 2 minus 8. So the answer is x raised to 2, y is equals to negative 6. Okay. But one technique, whenever you have a negative exponent, you can actually bring it down. Let's say I give you x raised to negative 1. Okay, this is the negative exponent rule. I can write it down as 1 over x. Or if let's say I have x negative 2, I can rewrite it as 1 over x raised to 2. In this case, if you will look at the exponent, y has a negative exponent of 6. So I can just bring it down to y 6. So as you notice, the negative exponent is already removed the moment you put it in the denominator. Okay? So let me just try to erase this one. Okay. Zero exponent rule. Any base excluding 0 raised to the 0 power is always equals to 1. So whatever number you raise to 0 will always be equal to 1. Whether it's 1 raised to 0 is 1. Even if it's 500 raised to 0 will always be equal to 1. The power rule. So there are three different items that you can see on the screen. Okay, if you see a base that has an exponent and it is enclosed in a parenthesis like this, it also follows that you just need to multiply the two exponents. Okay, so like let's say if I give you an example, a raised to the 3 multiplied to an exponent value of 2, then this is just a raised to the 6. Okay, now let's say this term here has a coefficient. Like let's say I put 2a cubed and this whole term here is raised to 2. It follows that you will also have to multiply it to 2. Okay, this is basically this rule. So you have 2 raised to 2, a 3 times 2, 6. Simplifying it, you will get 4a 6. So if it's a negative number, you just follow the rule for integers. Like let's say if I have b raised to the negative 5 times 2. So one is negative and the other one is positive. I will have b raised to the negative 10. And following the previous rule, considering that 1 over x is equals to x raised to the negative 1, then I can rewrite this as 1 over b raised to 10. So this is how it looks like. Now let's say you are given a fraction form. Okay, so for example, you have a raised to 2 over b, and the whole term is raised to 2. You will have to follow the same rules for the first and second one. The only difference is that this one is in division or in fraction form. So the answer is, you multiply the exponents, 2 times 2, 4. And because this one is also raised to 2, this one is b raised to 2. So let's say I will give another example. Let's say I have x squared y over z raised to 3. Okay, I will supply the exponent to both the numerator, the one at the top, and the denominator, the one below. 3 times 2 is x raised to 6. 1, this is y raised to 1 times 3 is y raised to 3. Z raised to 1 times 3 is z3. This is your answer. In the previous exponential example, I gave one item where it has a negative exponent. So whenever you see a negative exponent, you will just have to reverse its placement. So in this case, if you are given 1 over x, it just means that you can rewrite it as x negative to 1. So if you will have like a more complicated example, like let's say if I have a negative 1, b negative 1, if I want to get rid of the negative exponent, I know that by b negative 1, I can put at the top, I will remove the negative exponent, and a negative 1, I will put the one below. So these two are the same, in same way as this general rule applies, okay? So let me give a few examples. Let's say I have a negative 2, b over a 3. To simplify this, look at the values or variables that you can cancel. I can cancel out b. Okay, now I have a negative exponent here, which means that if I move this whole variable here below, I can get rid of the negative exponent, which means that I can just do 1, because this one is just 1, b over b is 1. Now it will become a raised to 2 times a raised to 3. Okay. Now, following the previous rule, when you have the same base, they both have the same a, you just have to add the exponent. Then it follows that I have 1 over a raised to 5. Okay, this is the first method. The second method, you don't have to, maybe you get confused with moving the variables if it has a negative exponent. You can do the quotient rule. So I already canceled b. So this one is division, right? So meaning it's a negative 2 minus 3, because this is division. So you minus or you subtract the exponent, which will give me a negative 5, which is also the same as 1 over a raised to 5. So if you can, as you can see, these two answers are the same. So I always tell my students, whichever method works well for you, that's how you do. But personally, I use the first method. But some students, they're more comfortable with the second method, so should be fine.